Hello, my name is Natália Yukari Kashiwaqui, and I'm a student of Biomedicine at State University of Londrina. The title of my research is Antibiofilm Activity of Biosynthesized Zinc Oxide Nanoparticles. To start off, bacteria are microorganisms that can cause infections in humans and exhibit two modes of growth, the planktonic mode and the sessile, in which the bacteria is part of a biofilm. A bacterial biofilm is a cluster of bacteria adhered to a surface and surrounded by an exopolymeric matrix. This matrix is composed of proteins, DNA, and polysaccharides, and it confers resistance to the biofilm, preventing antimicrobials from reaching the bacteria, thus making it much more difficult to treat an infection caused by biofilm formation. The biofilm formation starts with the adhesion of the planktonic bacteria to a surface. The bacteria starts to multiply and then produce the exopolymeric matrix. After that, the biofilm matures, and it is ready to release microcolonies that can form new biofilms in other surfaces. In this context, the nanotechnology have potential application in the treatment of infections, as some metallic and metallic oxide nanoparticles have antibacterial and antibiofilm properties. The zinc oxide nanoparticles present antibacterial activity against gram-positive and gram-negative bacteria. Besides, it is considered biocompatible, environmentally friendly, non-toxic, and inexpensive. The nanoparticles can be produced by green synthesis, which utilize extracts that can be made of bacteria, plants, fungi, and algae. These extracts contain many bioactive compounds that act as reducing and stabilizing agents, producing the nanoparticles. So, the objective of this project is to evaluate the antibacterial and antibiofilm activity of biogenic zinc oxide nanoparticles. First, the zinc oxide nanoparticles were synthesized using avocado leaf extract, and then its antibacterial activity was evaluated by the broth microdilution assay against Escherichia coli, Staphylococcus aureus, and Pseudomonas aeruginosa. In this assay, we tested different concentrations of the nanoparticles and, by observing the bacterial growth, we've determined the minimum inhibitory concentration, also known as MIC, which is the minimum concentration of the treatment capable of inhibiting the bacterial growth. After that, we evaluated the zinc oxide nanoparticles antibiofilm activity against Escherichia coli 042, a bacteria known for its efficient biofilm formation. We tested against biofilm formation, in which the biofilm is still in the early stages of formation, and against mature biofilm, which already has matured and it is protected by the matrix. The broth microdilution assay gave us different MIC values for the three bacteria. It is possible to conclude that gram-positive bacteria are more sensitive to the zinc oxide nanoparticles, as the MIC for Staphylococcus aureus was the lowest. For gram-negative bacteria, such as Escherichia coli and Pseudomonas aeruginosa, the MIC values were higher. The difference is probably related to the differences in the bacterial cell wall. The zinc oxide nanoparticles produce reactive oxygen species, which damages the bacterial wall. The gram-negative bacteria presents an external membrane that protects the bacteria against the reactive oxygen species, while the gram-positive bacteria don't have this membrane, being more susceptible to the reactive oxygen species. The antibiofilm activity assay results are shown in the graphics. It is possible to see that the 5 highest concentrations tested were able to inhibit 100% of the biofilm formation, while the 3 highest concentrations were also able to eliminate the mature biofilm. The zinc oxide nanoparticles can prevent the initial adhesion of the bacteria to the surface, impeding the biofilm formation to start, whereas the presence of the exopolymeric matrix in the mature biofilm protects the bacteria against the nanoparticles, being necessary a higher concentration of zinc oxide nanoparticles to completely eliminate the mature biofilm. Concluding this presentation, the zinc oxide nanoparticle synthesized using avocado leaf extract has potential application in products such as ointments and dressings, being effective against both planktonic and sessile bacteria. These products could be used to treat or prevent bacterial infections and burn injuries. The nanoparticles could also be impregnated in medical equipment where biofilm normally are formed. I would like to thank the State University of Londrina and the Basic and Applied Bacteriology Laboratory for the support during the development of this project. I would also like to thank the National Council for Scientific and Technological Development for the financial support.